Hello and welcome to this video. In this video, we'll be seeing between internal direct product and external direct product using U groups. Right? Remember what is a U group? U group is a group in suppose we are calculating Ux, so it will contain all the members which are less than x and are relatively prime to x. Here the operation is multiplication modulo x. Right? So this is how you define this group, U group. Correct? Now we will be seeing how we can relate this internal direct product with that of external direct product. So before moving on to the example straight away, let's recall various results that we have studied. In the first result, we have studied that if S and T are relatively prime to each other and UST is isomorphic to the external direct product of U of S and U of T, then we can write it like this: UST is isomorphic to US direct product with UT, right? So this is one result that we will be making use of. Why? Because we are now studying particularly about U groups to show the relationship between internal and external direct products. So here this thing is important that both S and T should be relatively prime to each other. Then only you can write it like this, right? The next result says here that if M, now this second result is a generalization of first result, where we say instead of some number n is equal to st, we now are taking m is equals to n1 n2 up to nk, right, such that the GCD of all the ni with nj's is equal to 1, right, for different I and j. So that means each n1, n2, n3 and so on up to nk that is relatively prime to each other. In that case, we can write um as u of n1 direct product with u of n2 and so on up to direct product with unk, right? So basically this is a generalization of the first result, correct? And the third result we have studied recently, which states the relationship between internal direct product and external direct product. It tell you that they are isomorphic to each other whenever we take the subgroups as normal subgroups of the group G, right? This is the result. So now clubbing all these results for U groups, we can clearly say UM, right? If M is written like this, n1 n2 up to nk, where all n1 n2 up to nk they are relatively prime to each other, then in that case we can either express this um as the internal direct product of these particular groups, right? And we can also express this as the direct product of these groups. So this is the result. Now let's see how we can apply it onto some U group. So let's consider the example U105. So here first of all let's see what is a group, and then we'll be studying about various notations, various representations of such kind. So if you see, U105 would contain all the members which are less than 105 and are relatively prime to 5. So how many such members are there? So we need to find the order of U105. Its order, the order of all multiplicative groups of such kind is given by this phi 105, right? The same number here. Phi is Euler phi function, right? This function basically tells you how many numbers are relatively prime to this number. So that is actually the definition of this group. So here in order to calculate phi 105, we can factorize it into 5 into 3 into 7, and then according to the properties of phi we can write it like this: phi of 5, phi of 3 and phi of 7. And what is phi of 5? 5 is a prime number, 3 is a prime number, 7 is a prime number, right? So when you calculate phi of 5, it would be 4, right? Because phi of some prime number is p minus 1. So accordingly, phi of 3 is 2 and phi of 7 is 6, right? All these results about phi and other details, they are very good explained in this concept subject of number theory. If someone has studied about number theory, then you will be very clear with these notations phi and how they function, right? So you see, in total we have 48 elements present within U105. So now it is quite lengthier for me to list all the elements of U105 which are present in this group, right? So here I am showing you it contains 1, 2, 4, 8. 3 would not be there. Why? Because 3 and 105 have GCD equal to 3 and not equal to 1, right? So all the multiples of 3 would also not be there. All the multiples of 5 would not be there. All the multiples of 7 would not be there, and so on. You can see eliminating all these members from these list of numbers, you have the elements of this group U105, correct? Okay, now once you know what is your group, now let's study about the behavior of U105. Now you know U105 could be written as 15 into 7. So let's first of all see what is our U7. It is because 7 is a prime number, it will consist of 6 members within it, and the members would be 1, 2, 3, 4, 5 and 6, because all of them are relatively prime to 7, because 7 is a prime number, right? In a similar fashion, you have U15. 15 is not a prime number, so here you have to list all the elements, all the members which are less than 15 and are relatively prime to 15. So they are 1, they are 2, right? 3 would not be there, right? 4, 5 would not be there, 6 would not be there because it is a multiple of 3 again. So all the multiples of 3 and all the multiples of 5 would not be here between 1 and 14. So you see we have these many elements present between U15. Now according to this result here, let me highlight it over here. You can express UM as UM upon N1 times M, UM upon N2 times of M, and so on up to UM upon Nk times of M. This is the first result about internal product. So here you have listed down your member here as U105 divided by 15 of 105 into U105 divided by 7 of 105, right? So when you divide them, both of them, you get 15 here. When you divide it by which number? 7, you get 15, and when you divide both of them, you get 15, correct? This is 7. So you get both of them as this. Now what is this U15 or 105? If you remember, we have the definition of UKN. It contains all those members X from the upper group UN, right? UN, such that when you take the modulo of X with K, it comes out to be equal to 1, right? So this is the definition. So out of U105, which contains in total 48 elements, we have to select those elements such that their modulo with 15 is equal to 1. So you see, obviously it is 1. It is 16. Why? Because 16 mod 15 is equal to 1. Then again it is 31. Why? Because 31 mod 15 is equal to 1, right? And so on. And we do not have any member in between because they either do not, is not present within this group or does not satisfy this particular condition, right? So therefore you have this set here. Similarly for U75, we are looking for the elements X mod 7 is equal to 1, such that this X has been taken from U105. So you need to see which all elements are present here. By some simple calculations, you can clearly see these elements are present here. For you, I urge you that you first of all write down all the elements of U105. It would be easier for you to understand this statement thereafter, correct? Okay, so once you have once you know what is U15 105 and U7 105, then you see that this set is isomorphic to U7 and this is isomorphic to U15. How? And I am writing here that this is isomorphic to the direct product. According to the result here, we have this isomorphic to UN1, UN2 up to UNK, right? So this is the result. So according to this result here, you see your set, this one which I have listed over here, when you calculate mod 7 of this set, so that means you are dividing each element here with mod 7 and taking the remainder. So you see, you get 1 here, 14 goes on 7, so 2 is left behind. Then 28 goes on 7, 3 is left behind. 42 goes on 7, 4 is left behind. 56 goes on 7, so 5 is left behind. And 70 goes on 7, so 6 is left behind. So you see, when you take its mod 7, you get this set. And what is this set? This set was U7, correct? Hence, you can write this as U7. Similarly, you can write this as U15, right? Because once you can calculate mod 15 of this set, you get 20 goes on 5, so it is 7. Then 25, not 20. We are calculating it with 15, right? So when you divide 22 with 15, it is 7. Right. Similarly, when you are calculating 29 mod 15, it is 14, and so on. When you calculating 43 mod 15, it would go on 2, you are left with 13, and so on. So you see, this set is basically U15 from here, right? So therefore, in this case, you are able to write it like this. Now, for the purpose